Welcome, dear students. Welcome to the YouTube channel of Department of Public Health Industry from Chettina Dental College and Research Institute. Here I am, Dr. Cyril Benedict Hedge, to start with the basic types of tests of significance. Okay, so as you know, there are two major types of tests of significance called as parametric and non-parametric tests. Okay, usually certain types of data sets are using parametric and certain types are using non-parametric. This is what we are going to see today. If you remember from the last class, data is broadly classified into qualitative and quantitative data. So when to use parametric tests? First, what is parametric? Parametric tests means it has some assumptions. It uses some parameters called as mean, standard deviation, or median, etc. Okay, so when mean, standard deviation, or median kind of parameters are used, when a test uses all these things, we can consider it as parametric tests. So the first assumption is when there is a quantitative data, we should use parametric test. Quantitative data means, as you know, the most common is continuous data. When a qualitative data is being quantified, then we should use non-parametric data, non-parametric test. What is this qualitative data being quantified? For example, you remember this satisfaction after ordering in an online aggregator like Swiggy or Zomato, or satisfaction after your ride in Uber or Ola, or satisfaction after number of stars that you give after watching a movie. Okay, those data like satisfaction or discomfort or pain, which usually differs from each and every person. There is no standardized scale for such measurements. Okay, a same movie will be liked by you, will not be liked by me. The same food would have been loved by you, I would not love it the same way. So such kind of data that usually do not be represented by means or standard deviations. Okay, such kind of data, when they are being quantified for the sake of summarization. So you remember this stars in food. 1 star means worst food, 5 star means you'll just love the food. So you see, the character of the food, or the satisfaction after or a comfort after eating a food is worst to best. They try to quantify it by assigning numbers to it, arbitrary numbers to it. For example, certain newspapers rate the film as 5 star, and certain other agencies like IMDb star the film as tens, 1 is to, I mean, from 10. So it differs, right? So For IMDb, greater than 8 is good. For other stars, where 5 star is there, more than 3.5 is good. So when you want to compare, you cannot compare like if 8 more than 8 here is good, you cannot simply tell half of 8, that is 4, anything greater than 4 is good. It's not so. Each has its own metric, right? So certain kinds of data that usually doesn't have a uniform measurement, when tried to summarize, they will assign some arbitrary numbers to it on their own to represent it. For example, pain. In dentistry and in medicine, we use something called as visual analog scale to measure the pain after third molar extraction, pain after a surgery, pain after some kind of anesthesia or recovery from anesthesia, comfort after recovery from anesthesia, okay, pain after LA, satisfaction that is the satisfaction of the numbness, anesthetic achieved, anesthesia achieved by LA. How better you felt anesthesia between two different LA agents. Okay, so lidocaine versus something other, benzocaine. So I would feel one is better. You would feel something is better. Your pain threshold and my pain threshold are not same. So when a number is arbitrarily assigned to a qualitative data, and for the sake of summarization, by assigning some numbers to it, it is being quantified. Such kinds of data should be theoretized or summarized using non-parametric tests only. Okay, so if the data is straight away quantitative, you use what is called as parametric test. When some kind of data is qualitative, but for the sake of summarization, they quantify it, you do what is called as a non-parametric test. The next assumption is, even though the data is quantitative, if only it follows normality. If only it is following normality, then you should use parametric test. Okay. What is this normality? Normality means the data is not so much skewed, that there is not much variance in the data. So how it is found out? Usually when mean is greater than 2 times the standard deviation, it is a thumb rule, we can tell the data is normal. If the mean is not greater than 2 times the standard deviation, it means the data is not normal. So what is the example for this? Imagine there is a group of people in class. You calculate their weight. There are so many variations in the class. Few are so lean and few are so fat, and there are extremes of weight. So usually the data is expressed as mean plus or minus standard deviation. Nah. So when you calculate their weight and you take their mean and standard deviation, you found out that, see, just for example, I'm telling, you find out that the mean plus or minus standard deviation of the weight is around 60.5 plus or minus 32.1. Here the mean is 60 and the standard deviation is 32. So if you multiply the standard deviation by 2, that is 32, the answer will not be less than mean, or not even 32, just 30. If 2 twice 30 is equal to or greater than mean. It is not less than mean. In such a case, as you can see, the standard deviation is very close to mean. Even if you multiply it by twice, the value will be near to mean. This kind of data means that the data is so much skewed or so much varied. If the data points are near to each other, that is, somebody is 55, next is 60, somebody is 62, next is 57, next is 61, next is 50, 0, 550 or 49, somebody is 70. This makes sense. If something is like the previous data that I wrote now is can be considered as normal. If some weight is like this 50, 89, 105, 39, and 40, 110, 98. See, some data is here, another data is here. Some data is so low, another data is so high. This kind of data is can be considered as skewed because there is so much variation in the data. So if that is the case, you should use non-parametric test. So if the data is quantitative, only if it is normal in nature or if it is achieving normality, you should use parametric test. If it is not achieving this thumb rule, if it is not achieving normality, you should use non-parametric test only. So summarizing, quantitative data is the first point. The second point is, even if it is quantitative data, it should have been accepting normality. So qualitative data that are being quantified is the first example of non-parametric or the first use case or indication. So even if the data is quantitative, if it is not normal, then you should use non-parametric test. Thank you.